Live from New York, it's Ask an Engineer!
Hey everybody,
Hello.
welcome to another fabulous and fantastic Ask an Engineer. Today we are asking engineers. There's two engineers on tonight's show. For double your engineer pleasure, double your engineer fun. It's me, Lady Ada, the engineer, plus Woz, Amanda Wozniak.
Hello.
Who's also an engineer. So we will just be engineering the hell out of anything we come across.
Between us, we have 4 E's.
That's true.
Because it's 2 double E's.
Well, I also have an M which has an E in it.
I also have that, and you have a CS too, right? So
Yeah.
like we've got 4
Yeah,
E's, 2
gaggle
C's, 2
letters.
S's, and then like a whole lot of other letters.
There's a ton of letters going on here. Okay.
Alright.
This beer.
Oh, you want to do this?
Oh yeah, no, that's true.
Do it up.
You
It's tradition.
have a lot of.
This
Look
was
at
a
that.
good one, so it's easy.
Jeez.
I've been getting practice. You know, got some good bone strength going from all of this stress concentration right here.
Yeah.
Cheers.
Also a lot of summer parties to go to.
Alright, on tonight's show.
Drinking.
The code is WOZ with a 0. W-O-Z. Gets you 10% off many kits in the Adafruit store. Use the code WOZ on checkout and you will get a nice discount. As you saw, Amanda Wozniak is a diode and she's on the show.
Are you a 1 in 4001 there?
Oh yeah, I'm a 1 in 4001 there.
Okay.
We'll talk about the show and tell. We'll tell you how to get on the show and tell. We'll talk about the new badges that we're going to give out to show and tell participants. Lady Ada was in the news and did a talk this week. We'll talk about that. Massimo from the Arduino project did a wonderful talk this week. We'll talk about that. One of our bloggers, Dan, did an awesome OLED Lego train schedule. We'll talk about that and how you can vote for the Adafruit Hackerspace Lady Ada workshop. Make Magazine has an interview that I did with John Janier with Lane from Dork.pdx.
No, OSH work.
Now OSH Park. We'll talk about 2 requirement documents that a real life school teacher wrote on how you can get a badge for programming or a pad. We'll talk about Ask an Educator. We have new tutorials that we updated. We have lots of new products, some that are back in stock, some things that go inside panels for panel mount, and we have these amazing, gorgeous screens that, of course, work with a variety of things, including the Raspberry Pi. We'll have, it's not out yet, with something very fun and special. We'll answer your questions. We'll have a trivia question. We'll have a cat.
Yeah.
All that and more on Ask an Engineer. Which, by the way, look at these little banners I got. Isn't that nice?
Yeah, they're very nice.
Look at these.
They're all nice.
Yeah.
So much design you have.
Yes. A little bit of a programming note. Ustream was kind enough to give us ustream.com/Adafruit. And if you go to Ustream...
Forever?
Vanity URLs.
Vanity URLs, they call it.
Ah.
Just like vanity license plate, except for on
The internet.
So they
You
use it.
are driving the Cadillac of the internet.
We do have a vanity URL shortener, adafruit.it.
Yeah.
Yeah.
Yeah, that's cool.
I mean, it makes it all fit on the packaging,
Yeah.
which is nice.
It's
Yeah.
also like cute.
It is.
It's like youtube.be. It's cute.
Yeah. So on Google Plus, we have these different banners, and people could vote. So we had this one. Oh, robot.
Yeah, that's Adabot.
Ask an engineer.
Oh, we had you.
That's me with the wallpaper design.
We have wallpaper that we're making. Anyways,
Yeah.
so we got that going on. All right, Woz, you're in town.
Yep, it's true.
Thanks for coming by.
Hello.
I am not a hologram.
You're not a hologram.
Not a hologram.
Actually, you know, one day it'll be funny. We'll probably have a
I know.
hologram. Yeah, I know.
Well, there was that really awesome take your family portraits with, projected
Skype,
Skype. That was really
yeah,
nice. It looked really good.
Okay.
Very good job.
So just a reminder, everybody, the code is WOZ with a 0, 10% off. The code expires at midnight, so make sure you buy stuff so we can keep having WOZ out here
Don't be late.
and feeding the cat. He eats a lot. All right, let's talk about the show and tell. What was on the show and tell, guys? We got 3 people, 4 people.
There were a lot of projects. So Mikey was back with his with sending geolocation and telemetry data over the ham network.
Yep.
And this time he's iterated through the project a bunch of times. He's been working on it for a while, and this time it was in a super nice laser cut enclosure that his friend made for him. And it all came together and seemed like super solid. Like it looked like you could drop it from lots of different things and it would hold together. Then Jeff, who is a home brewer, had set up his kegerator to report to this thing that's like Foursquare for beers, like checking into your favorite beer.
Yeah, it's called Untapped.
Untapped.
Yeah.
And he was using one of the nice inline flow sensors and a Arduino Ethernet to just upload that.
Yeah.
And then James had, this was awesome, he'd set up a IR camera, or the I2C camera from the Wiimote, and he had 3 IR LEDs on a heads-up his headset for an Xbox controller, and what it was doing is the camera from the Wiimote was looking at these 3 IR point sources, mapping sort of where that was in its XY coordinate space, and then transmitting that information to his Xbox controller over XB, and I believe he was using a NetDuino and C# to program everything together. But then what the module attached to his Xbox controller did was supersede one of the joysticks, so that his head was actually taking the position of the scan in the game, which makes like walking through a game super intuitive, and it was really nice.
Yeah. And then Chris had some mic problems, but he'll be joining us next week.
But I think his thing involved LEDs because there were colors.
Yeah.
There's ambient light.
Okay. We got some low bandwidth.
Yeah, it's a low bandwidth.
No.
All right, the show needs to be
But
restarted.
it seems to be okay because it's going down, then it goes back up.
All right, Lady Ada, how do people get on the show and tell?
Super easy. Go to my personal Amorphreed Lady Ada Google Plus page, and then every once in a while I post up and say, hey, respond here if you want to get put in the Google Plus circle for show and tell, because I have 500,000 followers and we can't have 500,000 people show up. But if you put your name there, I will add you to the circle, and you'll get an invite on Friday night at 9:30. So if you ever want to in the future show anything, do it now, and yeah, you'll get a notice when your project's done.
Okay. A little bit of a housekeeping note. We had a contest on Google Plus. So the show and tell is getting so popular, people are saying, oh wow, that's the as featured on the Adafruit show and tell. So people are showing these at maker fairs, at events, all sorts of things. So we did a little bit of a contest for people to vote, and here's a winner.
Yeah.
Nice.
So in the future, when you're on the show and tell, we'll send you out a sticker.
Yeah.
Maybe we'll even do retroactive ones. Do you know that we have like 26 hours of show and tells already posted up?
What?
Yeah, it's intense.
Yeah, we have
a lot of projects.
We've been doing it for about a year.
Yeah.
Right? Or half a year?
Yeah.
That's a lot.
Since Google came out with it.
Yeah.
Back when it didn't even work, but we still like
It barely
did it.
worked.
Yeah. It was totally cool.
Okay.
Anyways, so that's the ones, and we may still do these other ones. We're trying to get permission from Google, but it's
I
always
like it the most, though, the one that
Yeah,
you
because
picked.
it actually looks like the actual as seen on TV.
yeah. So I
it's
think,
nice.
we think it's pretty good. Okay, this week
Throwback.
you did a talk at the Rockefeller Foundation.
Their
Lady Ada.
centennial,
The
yeah.
Centennial. What did you talk about?
I like how the head's on top of my head. I talked about I talked about open source hardware. So Bree was there, and Bree was speaking about 3D printing. And he actually talked about the Met Art project they did, and then a guy from the MIT Sensible Cities, the Media Lab group, he was there too. And then the fourth speaker was a guy who does no-kill meat, sort of like they're trying to get muscle cells to breed in a petri dish so they can make like petri dish shaped steak. So I spoke about basically how it was a really short talk. So I tried to talk about like how open source hardware will how that affects developing countries and their technologies, and basically I was saying like, hey, the cool thing about open source hardware is you don't have to worry. Except what I thought was the point was that you separate the intellectual property development from the manufacturing, because manufacturing can be done in East Asia so cheaply now that, but they don't necessarily know how to develop the applications that are desired for these nations, so that you can be in a developing nation and design a technology that is very necessary for your area, and you don't have to worry about like, shit, I can't manufacture stuff anymore. And you can also share designs within communities and then have them manufactured in China. And the cool thing is that even if it gets ripped off, it's totally cool, because all you want when you're designing these technologies is to get the lowest cost available product.
And if it gets ripped off and people are making it in more volume, then
it's to your benefit.
Cheaper,
So it is this one weird, cool exception where like a lot of people have, they don't like that the IP is separated from manufacturing. They say, well, I designed it, I want to manufacture it and then get those margins.
Right, but you can't do that if, if you're resource strapped already, then you get nowhere.
Right. So I thought it was an interesting idea, and I had some examples of where this could be used, and also that open source hardware, we could develop open source hardware, and if you get a large enough library of information, then the intellectual property is also outsourced. So in the end, it's kind of like that fellow on the show and tell James was talking. He didn't really know electronics, but that's okay. Like what he did was actually like what some people would consider like well, a few years ago it would be considered like a thesis level electronics project.
Yes.
And it's like you can actually do that knowing nothing about electronics, which is really, really cool.
He was saying that he was going out to the community and saying, look,
like, I did
everything you
tutorial.
need, someone else has already done it.
We
so
went
just
tutorial,
like
right?
put it all
And so
together.
he put it together, and so nobody had done his particular project. He outsourced the intellectual property, and then if he wanted to, he could also get it to mass manufacture. And the best part is he may not even have to manufacture. So that's basically what my talk was about, which I thought was kind of interesting. And we went into these breakout groups afterwards, like a bunch of people, policymakers and people who work for NGOs like NGOs Without Borders, and it was kind of interesting because I was kind of hoping we wouldn't just be like, okay, let's design like a solar powered like lamp, whatever. But in the end, they actually came up with a very interesting idea, which is this group, after like talking for a few hours, kind of came up with the idea, what is the most important thing? And the most important thing that we decided was actually a website that was kind of the Wikipedia of like sensor technology and manufacturing technology, which is actually more useful. So basically,
comprehensive reference for what you want to do.
Comprehensive reference, because people, for example, like, I know where to get like all these sensors and parts, and that's like basically what I do here at Adafruit. Is I'm like the resource supplier and purchaser and sourcer and all these good stuff. But a lot of NGOs don't have that capability, and so they want to like use a water flow sensor, and they actually don't even know where to start.
Right.
And so if there was a resource available to connect them with manufacturers of these technologies, that would actually be really useful. So we told the Rockefeller Foundation to like make this, but I don't know if it's going to happen.
Well, that's really exciting because that's actually, I was recently at the D-Lab, I forget which anniversary, if it was the 10-year anniversary.
The Stanford D-Lab? Or?
No, D-Lab at MIT, which is the developing...
Oh, right, that's
developing lab.
Amy Smith. Yeah.
Amy Smith. Yeah.
Third Amy Smith.
Yeah, not Amy L. Smith, but Amy Smith. D-Lab has been focused on basically her philosophy, and it's evolved. I mean, she started D-Lab with the Edgerton Center, and it started from, we should like do these things to help developing countries, to the, well, you need to go there, like they're the best designer, they know their applications and their needs the most.
We actually as engineers shouldn't be designing for them. They should be
designing for themselves.
Yeah.
And that's the whole point, is like people in resource starved countries and people in poor countries are not intelligent. They literally just lack resources.
Yeah.
So if you give them research resources and you give them a way to be able to get something manufactured to how they need in a way that they can afford without having to invest in infrastructure, it's really the best thing you can do.
Right.
And that's what a lot of these labs do.
What I thought would be kind of cool is if EEs went through and like, in the end, I actually ended up being like, well, that's exactly what I'm doing, like going through like every sensor that's available out there that's kind of a low-cost sensor, and putting enough open source hardware resources around it so that somebody could be like, shit, I need to like measure like humidity,
right,
for some like project, or water levels for some project. What sensor can do that? And then there's like example code for Arduino, which can then be adapted to whatever low-cost processor they want.
But you can take it further. So because you've got all of these different people, like James, putting all of these different pieces together in different applications, if people start writing about how they're using it, and when, for example, this humidity sensor works, but it fails under these conditions, so you can also start putting in the applications information.
Right.
Like, this is the application that you want to use it in. If the environment's really, electrically noisy like this will fail, but if you're using it out in the woods, it'll be fine, or it's really happy on wall power, not happy on battery.
Yeah.
And putting that extra, because a lot of times I think what happens with people who are not used to doing engineering sourcing, and I know this definitely comes up in my job because as one of the staff engineers at the Institute, I'm helping scientists and researchers who don't have an engineering background try to get the equipment that they need to do their basic research. And a lot of it is knowing, that flow sensor is great, but it only really works with flows above this rate. Like if you try to do less, then it actually can block the flow, it can lead to problems, it's not accurate. Yeah. And so having all of this basically engineering application metadata up there is really super useful, because an engineer is valuable because they learn that through expertise and through mistake. And you can't get over people's need to design it themselves and make their own mistakes to learn, but you can give them a better underpinning.
But it would be better if they didn't have to like burn out
if they didn't have
to learn it.
Yeah, it would be best if failure was not the only way to learn.
Yeah.
And by putting all this experiential information in one place, then that helps everyone.
Yeah, that's what I think is so powerful about like open source hardware, as it is in like the U.S. at least. And my hope is that, like a lot of people might say like, oh, you're just designing toys for like, rich white people in the U.S. I'm like, yeah, now, but eventually this stuff will seep into like every culture. I mean, at some point we'll have Arduinos that are so inexpensive that it'll be in every school, and you'll actually be able to do sensor technology no matter what country you grow up in.
There is actually a job description right now at the Bees for a staff engineer position, and it has in there experience with Arduino-based systems.
Yeah.
And
Which is totally fucked, right? Because you think it's a microcontroller.
10 years ago, everyone was like, oh, whatever, like, Arduino is just a toy. But it's turned into so much more.
Well, because all the grad students are using it.
But, I mean, other people use it too. It's just, this is how things become real cultural frameworks.
I kind of think of it as like the libc of electronics. Anyways, we should probably move on.
Okay.
Yeah, let's keep going.
Let's go.
Speaking of talks to save the world, Massimo did a TED Talk.
Yay! Actually, I haven't had that chance to see it, so no spoilers.
Well, no spoilers, but I will say this: some cameos were in there. Sylvia, super awesome Sylvia was in it,
nice.
Yay.
and also he pointed out Lady Ada.
Oh, that's nice.
Yeah, very nice. So I think Massimo is probably one of the best people that. He doesn't talk about the Arduino project specifically. He loves to talk about what people are doing with it.
Yeah.
And I think that's the most powerful thing.
Yeah.
About what people can do with it. And like here we are, probably going to be up to 1 million units soon. And there's Leonardo without headers. It's basically $20. Basically.
It's not quite yet,
It's
but
so close.
as it gets manufactured more and more, the price will come down. It's so new that you just don't have the volume yet.
Yeah.
But I remember when the Arduino first came out, it was $40, and now it's $30.
Yep.
And some places are even selling it for like $28.
Yep. Okay, let's keep moving. This was on our blog. Dan is one of our bloggers. He did a really cute project. It is a Lego set with an OLED train schedule.
It's so cute.
Super cute. So
they used our little miniature color
and he shows how to
OLEDs.
make it. And look at this. And he has all the code. It's on GitHub. And we wanted to do some Lego projects because we still need your help. We have almost about 2,000 votes. We still need 10,000. So if you want to see not only the Lady Ada Hackerspace, the Lady Ada workshop happen for real, you have to go and vote. It's a little bit of a pain in the ass. Sorry, Lego made you it's easier.
It's harder than Kickstarter.
It's harder than like giving money on Kickstarter. But if this works out, the next one up, we're going to do Amanda's biohacking space, Carol's robot surgery lab, all sorts of things.
I love robot surgery.
We'll change the way people think about Lego from the outside, because there's lots of like Lego sets, but none of them are like girl engineers, girl scientists. There's like veterinarians and beauticians, but like not engineers.
Also, who doesn't want to have a Lego surgical theater?
That's fun.
Right?
That'd be so cool.
That's the best.
That's so much better than like
imaginative play about mad science. Yeah. Come on.
And by the way, we'll have a project during the week that shows how to add more electronics to Lego. We're starting to think about maybe having packs for people who want to make Lego more electronic-y. Okay. Anyways, we're doing that. Next up, how many people out there in the chat know about Lane's Dorkbot PDX service, open source hardware park? How many people? Do you know? How about you guys? Have you ever heard about it?
Yeah. You've never seen the Dorkbot PCBs?
All those
PCBs?
I mean,
I've heard about them, but
yeah.
I've
never used it, but I have heard about it because I make so many PCBs and I just send them out these days.
Here's John Janier and I teamed up. It's a buddy cop movie.
Yeah. Who's the good cop?
He's a good cop. I'm a bad cop.
Who's the rookie?
That's a good question. I don't know. I think I'm the crazy one.
You're like the old.
He's 1 minute away from retirement. He doesn't need this crap.
You're that guy. Like,
Anyways, so we interviewed Lane. I met him at Maker Fair. He has these little purple glasses, and I said, "You're a Maker superstar. You're a Maker hero. I would love to have an interview with you on Make, and maybe turn it into a bigger profile for the magazine." And then John Janier said, "I've been interviewing him for a while too." And I said, "You know what? Let's just like super twin this thing and like team up and do it." So it's a giant interview, and if you like Lane's service, you like the awesome PCB that he does, read all about it, read how he does it, why he does it. The best part in the comments, you can just look at all the people saying wonderful things about Lane.
Aww.
Very cool. You also, yeah, so that's really fun.
Okay, cool.
Okay, next up. We're on to next up we've got 2 new skill requirements. We have a real life school teacher, Adam Kemp. He does the Ask It Educator section, and then he also does something in the Adafruit Academy, which I guess I can show real quick, which is is our little section that we're growing, and then it has all the skill badges that you can look at his requirement sheets, and if the kids happen to do all the right stuff in the like iHeart metric thing, then they can get the little badge at the end. And this is a real life school teacher. So
yeah, and it's got the sign off.
Yeah.
Someone has to sign it.
Yeah.
Someone has
You
to
can't
sign
just
it.
check
Yeah.
it off yourself
You
like you would
can't now.
your junior high band practice.
So anyways,
time requirements.
we have Learn to Program, EagleCAD. Don't worry, we have KiCad. We have that coming up. We have that too.
But Eagle's not open source.
Yeah. And then we have
An outburst.
we have a few others. The other Ask the Educator ones. What software do you use to design a 3D printer?
That's a tough one.
Yeah.
How can I teach electronic concepts to first graders? And then Bill Porter, which is also one of our educators on there, he said, food for thought, teach the teachers STEM, then the students, because the teachers don't know STEM. Some people are also calling it STEAM because they want to add art, but STEM, STEAM, whatever.
It's cool.
Okay, next up, before we get on to the rest of the show, we have some updated tutorials. The breakout board, the thermocouple, and this is all part of the Adafruit learning system. And this is the first
I
time.
actually added a whole bunch today.
This is the first time. This is the first time Waz has ever seen this, I believe.
It's true.
Yeah, this is the first time Waz has ever seen this. So this is our new Adafruit learning system, powered by Adafruit Learning Technologies, and this is in beta. So one of the ones that we said that was new was this
breakout
one.
and the
Yeah,
thermocouple.
this one here. So you can see it's super clean. There's no ads. It's just it's all about business. You'll be able to print a beautiful PDF shortly. We're transitioning all of our tutorials from our old system to the new system, and it's just gorgeous.
The workflow is so nice, like that. You've
Yeah.
got the sidebar, and you're very Web 3.0.
Yeah. The other thing that's really neat is depending on your screen size, if you're on an iPhone, if you're on an iPad, if you're on an Android device, the myriad of those, it'll rearrange itself and it'll
It gets rid of elements and resize elements.
yeah. So if you're
It's got workflow.
yeah, and the tilt sensor, if you're on a smaller device, it'll collapse the documentation, so you can see what's going on here. So it's hard to show.
You don't have the menu, and the image is also dynamically resized.
Yeah.
But
That is really sweet.
but it doesn't use image resizing. It actually back
Yeah.
end resizes it using image magic. So you always get like beautiful. You don't get the weird like chunky.
Yeah, the weird
resizing.
effects. Yeah.
Yeah.
I hate that.
Someone wants to know if there's a tutorial for the coin acceptors. Yeah, we'll have one of it.
We don't have one yet because we're working on the tutorial system. But the
Yeah.
the coin acceptors are pretty simple, so we don't have tutorial for them.
Okay. So those are the things that we got on. So once again, before we get into new products, code is WAS. It's 0.
Yep.
WAS. 10% off. Any things? All right, let's move on to the new product, guys. New products.
And we're back. So apparently there is a fight to the death,
Yeah.
which is related to barbecue sauce
What?
of the future.
Huh?
The Mike Tyson, the vendor.
Yeah, I was telling you
Oh,
about
this is
that.
not- okay.
They're
Barbecue
buddies
sauce.
now.
Oh, look, we have mega bandwidth, so we're good to go.
Oh,
Okay.
yeah. Yeah. By the
So-
way, if it ever cuts out, guys, we'll keep trying because that's what we do.
Until it's like 20 minutes of trying and it's not
Yeah.
working, then we give up.
All right, we have. This is by popular request. These are panel mount cables.
Yeah. These are cool. We got B, USB-B, USB-A, and Ethernet, or just Cat5. And I can show these on the overhead too, if you want to go do that.
Yeah, I do.
Overhead.
So this one is the Ethernet. So yeah, there's 2 screws, and they come out the back, and you can. These are just M3s, and you can replace them if you want. If you need like longer screws. And it's basically just a little extension cord. So you plug this in, and then you can panel mount this. And you can use this with a patch shield. This is good for passing sensor data. It's got 8 connectors, and the wires are really cheap to get. We also have a USB-B. So this is again a B extension, and there's these little ears, and you can screw this onto a panel mount. This is good for like if you have an Arduino or something that uses a B connector, and then you have it in a box and you still want to get to reprogram it. You can, and you don't have to have it at the edge of the box.
Are these
Yeah.
waterproof, Lady Ada?
They're not waterproof because the contacts are exposed, and when you plug it in, it's not waterproof. They're somewhat resistant to dirt, but
Yeah, the Ethernet connector has a flush face.
I mean they're molded, but
Right.
they're not. If you imagine like the cable's waterproof, but then the contacts aren't,
Yeah.
so it's not waterproof. There's no such thing as.
Someone wants
exposed
USB-B
waterproof.
male to USB micro B female. We'll try to find it.
Well, we'll see what we can do, but this is kind of what we got. I asked them for micro B or mini B, and they said they don't have it. We might be able to get a small adapter that just goes from this to.
Yeah, you're better with an inline adapter.
Do you know what gauge wire it is?
It's on the product page.
Okay.
But and then this is a USB-A to USB-A female, and again there's little ears.
Is there one for HDMI? That's pretty new.
So this would be good for if you have like a BeagleBone or a Raspberry Pi or some other device that is a USB host. You can again plug it in inside and then have this connected to the cable. So this could make enclosure design a lot easier for people, and I like the idea. And they're pretty short, so you can wrap them inside of a small box.
Yeah. The only one though that you could make water resistant would be the Ethernet, because that's the only one with the flush phase.
But we have like a fully waterproof Ethernet connector already.
That's true. And you have the cable glands for other things.
Yeah.
Okay. Next up, this was kind of the big release this week. We have these little tiny TVs. They're super cute.
They're adorable.
Yeah. Look at this. So here they are. I'll show lots of different pictures. You want to talk about some of the different sizes?
Yeah, we have 4 different sizes because I couldn't make up my mind. We have 1.5, 2.0, 2.5 and 3.5. So it's kind of a full range. We'll have 4.3 soon, but there's so many more options of 4.3 I want to test them. These were, it was kind of hard to find these small displays because it's just rare to get a small television.
Yeah. Okay, do you want to show this on the overhead?
I can show them one at a time.
Okay, and we plug these into the Raspberry Pi because everyone is asking about that. So
yeah, I mean you can use anything that has NTSC or PAL out, and so so these come with a little cable for power. You can power them from like 4.5 to 12 volts, and there's a composite video cable as well, and they take PAL or NTSC and they auto switch between the two. And then on the back, there's a controller board there's a button that you can press to cycle through brightness, but for the most part, it's pretty good to go out of the box. And there's a boost converter, or a buck converter and a boost converter here for the LED backlight, and also I think to bring it down to 3.3 volts. If you're like super hardcore and you really want to run this off of 3.3 volts, you might be able to trace through the buck converter and then connect up directly to the 3.3 for logic, but I don't know how to do that, so it's up to you. But this is a super small television. And it's full color. It's pretty crisp. Like, it's not like you can't read small text on it because the resolution's not great. It's like, I think 160 by 120. You can check the product.
Will there ever be HDMI versions of these?
No, it's very unlikely to see an HDMI decoder. That's why we decided to go with NTSC or PAL. We have digital displays, and then now we have NTSC PAL displays.
What size is that one?
This is the 1.5 inch.
Okay.
So then I'm going to show the next one, which is the 2.0 inch one.
This is 2.0?
Yeah.
The controller boards are a little different for each one, but it seems like they use the same chipset.
Yeah, it's the same
they have
controller
different
set.
controls too for some of them.
Let's get this.
Yeah, it's super bright.
This one's super bright. Maybe I can change the brightness. I mean, it's brighter. You can see I'm changing the brightness.
Yeah, you're making it brighter.
Yeah, but then it cycles back.
Oh,
You can kind of see it. Yeah. So this is a 2.0 inch display. And it's a better resolution, and yeah, it's a lot brighter. These are all pretty nice small displays.
What's the biggest one? 3.5 inch?
The biggest one we have right now is 3.5 inch.
Yeah.
This is the 2.0 inch one, and then.
So it wants to know the letter box bars are caused by the Raspberry Pi, right?
They're caused internally by this display because the resolution of the display, I think, is not exactly the same as the output of the Raspberry Pi. So if it was exactly the right resolution, it would be right. But I don't think I think you might be able to configure the Raspberry Pi to be the perfect resolution. But as is, it's expecting HDMI, and so I don't know. There's probably some registers you can adjust.
And then someone wants to know, are these all the same resolution?
No, they're not.
You have to look on the product
page.
Look
on the product page. They're all the bigger ones have slightly better resolution because they're bigger, and also the pixels are larger. So this is the 2.5 inch one.
Yeah. And do you want to show 3.5 and then we'll move on?
Yeah. So I'm showing you. Yeah, but you'll see because it's not expecting it to be XVGA out, and that's probably what's up with it.
Sweet RoHS.
And then
I love how everything's RoHS compliant now. There you go.
Yeah, Messenger.
Yep.
Do you think they could handle vibration if they're attached to something with shock, and then someone wants to know how hardy these are?
Well,
so with the flex displays, they're quite delicate, and so I actually whipped one just like trying to mess around with it, and basically if you're really careful and you attach the display and the control board to something really solid, it should be all right, and tape down the flex connector. But they're not meant for heavy-duty vibration. I mean, the 3.5 is sometimes mounted inside cars as like a GPS unit display, but it's not, you know, it's not like ruggedized for outdoor use.
Yeah, it seems like the failure point would be the ZIF connector to the
No,
PCB.
it's not. It's the flex.
Is it actually the flex?
Yes.
Okay.
Trust me.
I trust you. I'm looking at it,
And then
they're
this
both.
is the 3.5.
Yeah, that's pretty
And
great.
the 3.5 is actually kind of nice because it actually has a menu system, so you can change the brightness and the color. You can change the color.
Are they backlit with LEDs?
These are all LED backlit, and this is the contrast, so you can see how like I'm really messing to make it look good on this. I'll probably need to have high contrast, and that's stored inside the EEPROM. This is a more advanced controller, so it has an on-screen menu system. So the 3.5 is kind of what I think is, you know, you can actually read text on it at this point, and it's fairly usable as like as a basic display. So
viewing angles, someone wants to know.
check each product. I don't know the exact viewing angles for each display off the top of my head.
Okay. These are fun.
There you go. So reset it. So yeah, so we have 4 different display sizes. 3.5 is kind of what I think will be the most popular. But if you need to have a delicate, if you need to have a small or compact project where you need to have just a really small display, this will definitely do it for you.
Can they be calibrated to ISF D65?
No,
Okay.
these are NTSC displays,
Okay.
not HDMI displays.
All right. And with that, guess what? That's our new product segment.
Yay.
That's it. Just a few this week. New products. That was new products. All right. We got some surprises.
Okay.
We're gonna do a little "It's Not Out Yet, Don't Ask."
Yeah.
During this section, don't ask questions, folks. Wes can ask questions. He's here.
Well, why don't I tell the stuff?
Yeah.
Yeah.
I already asked
Okay.
all my questions.
Top secret. Here we go. So we have the latest beta of our app, and this is Circuit Playground. It is becoming a massive app that people are using in schools. Kids are using this. If you want to, I can zoom out if you want me to, unless you want to.
let me,
All right. So this is not available yet. It's beta. Why don't you do a tour, and then at the end, maybe I could tell you a few things to click.
Okay, so we've added to the IC pinouts not only microcontrollers but also op amps. So you've got your classic single, classic double, and classic quad op amps. So nearly all op amps use the same pinouts. It's pretty rare for one not to, so this will be good for nearly everything. And then to go along with it, we also have a whole mess load of op amp calculators. So we've got just a buffer diagram, which is handy, inverting op amp, and you can type in your voltage and your resistors, and it will tell you not only what Vout is based on VIN, but it also gives you a little warning telling you what the VCC and VE are. It's kind of hard to see though on the small screen. And then we have non-inverting as well. So your classic non-inverting amplifier. We have a summation amplifier. It shows only 3 here, but usually it's good enough. You can always put in 0 volts if you don't want to have, if you only want 2, and then you can use the equation if you need more than 3. We have a basic integrator, and it will calculate the RC constant for you. Likewise, differentiator, it will also calculate the RC constant. Current source, which is really handy if you want to generate a constant current source, and then I guess maybe you could switch around and do a sync if you wanted to as well. And then finally, basic differential amplifier for your small differential circuit amplification. So that's the 8 op-amp circuit. Maybe we'll figure out a ninth one to fill in the spot eventually.
And if you move it over just a little bit so you can get it on the screen that way. Move it over. Yeah, there you go. So go ahead and click the Adafruit section.
Yeah, we also
So in Adafruit we have a few things. Go to the learning system. This will automatically take you to the Adafruit learning system that's optimized for, it's a little blurry. Can you move the camera there? There you go. So our entire Adafruit learning system works and looks great on the.
I really like how bright it is.
I think it's not
Yeah,
just
too
not
bright.
focusing. Yeah.
There you go. Anyways, one of the other features, and I could show this on not only an iPhone but also the iPad. If you go back.
What to the?
Yeah, let's go back to the app here. So a new one is the show and tell. So this is the new feature.
Crap, sorry.
Hey, look, we're broadcasting.
We're broadcasting. I don't have pointing a finger, so you want show and tell?
Yeah, the show and tell, it works on an iPhone and an iPad, and I'll show you here. I'll do this too. This is the iPhone version, it's the iPad version. What's great about this is you can choose a photo in the show and tell section from your photo library, and let's say if I took a photo a while ago of a cool project I did, maybe this is the Lego set. And what this does is it sends it to Adafruit, and pretty soon you'll be able to, or you could just use the camera. In fact, I could take a photo right now of Woz. Say hello.
Hello.
And what this does is allow you to send a photo of your project directly to us, and we'll have a gallery. So this works on the...
Do you want me to try it?
Yeah, well, we can do from camera here.
Okay, hold on.
Wait, it'll switch up. Look at us.
Whoa.
No. Yeah.
Okay, so now I press the button? No.
Yeah.
Okay.
Yeah, and then you click use, and then this sends it off to us, and it has all the information. And we think this is a great way to allow people to send their photos. It's under Creative Commons, so you would send it to us, and it's enhancing our show and tell.
Yeah, so you can do show and tell even if you can't show up at show and tell. You can do snap a photo and tell.
Yeah, so this allows people to do something cool with Adafruit products or absolutely anything. Send it to us. We'll have a big gallery. We'll give away badges that way. And this is all part of the Adafruit learning system, Adafruit learning technologies, the iPhone and iPad app. A lot of this is all HTML5. It works everywhere. So that's our It's Not Out Yet. Don't ask.
That's awesome because engineering Pixar didn't happen.
Pixar didn't happen. And then we have one more thing. This is a big surprise. Phil Burgess, Paint Your Dragon, who's in the chat right now.
Yeah.
We sent him a simple email. Make this, and we sent him a photo of the Back to the Future clock, and he actually made it. So on Monday we'll show you this. Not only did he make pretty much an exact replica, or pretty close to, from Back to the Future, but he got the DeLorean.
He got
and
an
then,
RC DeLorean.
Yeah, and I got a little bit of, it's going to play a little of you listen to use.
I don't mind, but you better promise me I'll be back in time.
And here he is right there.
Yeah, you got it.
But you better promise me I'll be back in time. Gotta get back in time. I don't mind, but you better promise me I'll be back in time.
Yeah. So anyways,
Back in time.
that's It's Not Out Yet, Don't Ask.
But that's coming out next week early, right? And you're going to
Yeah.
push it up?
I want him to build me a Stargate. That's the next one up.
We are working on that.
Working on it.
Nerd
Okay. All right. It's time for our engineering questions. That's why everybody's here. Ask your engineering questions. Go,
Especially
go,
for
go, go, go.
Woz. Ask Woz engineering questions.
That's was
'Cause
really
she's
complicated
here-
engineering. Okay.
She's here to answer your questions.
Ready. Did you write the content management system for the new Adafruit learning system? Is it available somewhere for other sites to use? It's really nice. The first part of the answer is yes, we wrote it. Tyler and Justin, the Kubros, along with Lady Ada and Daigo and myself worked on this. It is not available for you to download yet, but we're an open source company, so you can imagine one day.
It's
It would
barely
be.
even working.
Once it's through the beta testing, I'm guessing, and the alpha test,
and the alpha and the gamma testing.
Yeah.
and the omega testing.
We would
Don't
like to
forget
be the
omega testing.
WordPress of tutorials one day.
That'd be cool.
Yeah. Okay. All right. Keep asking your questions.
Ask engineering questions for Woz.
All right. I found myself a 5-volt, 200 amp switch mode power supply. What should I do with it?
5 volt, 200 amp. Huh.
You could, I don't know, make a capacitor bank.
I mean, you could charge a lot of capacitors really, really quickly. But if you charge them up to 5 volts, it's not like the discharge. Like,
The problem is you have to have really thick cables for anything you're doing. So it has to be something that runs off of 5 volts.
No,
And you can move
yeah.
the cables for too.
Normally, the really exciting power supplies are the ones that are high amperage and high voltage, because then you can do things like Jacob's ladder or like boost it to kilovolts or.
See, what uses a 200 amp 5 volt power supply?
I have no idea. A really big motor, like a 5-volt motor that
But,
you could drive like.
5 volts. They're all AC at that point.
I know, like I don't know any DC motors that like.
Anything is like 12 volts, 5 volts.
Yeah, I mean everything is usually like
You could
24 volt,
you could
100
run like a
watt
lot
motors.
of like hard drives. I don't know.
You could keep yourself in USB for the rest of your life.
Yeah, you could charge up.
Like you could charge every USB
you
device.
could charge up every USB device.
Ever.
Ever.
1C current.
That's a good use.
You could just like charge.
You could charge 200.
You could charge tons of batteries. Tons of
100. You
batteries.
could charge up 100 like iPads like instantly.
You could charge 200 1 amp. I don't know any 1 amp battery. Yeah, but 1C.
You could create a USB
Yeah, 'cause-
like toaster oven, and then you could power.
That's
that.
true. Actually, yeah. Aren't a lot of coils like thermal coils run at
They are very
low voltage, high current?
Yeah, very low voltage.
So you could do like heater apps.
Okay,
with
so
that.
you could build it yourself a little toaster oven that runs off of USB.
A USB toaster oven.
and
You could
then-
you could build a USB PCB oven.
Yeah,
Okay.
yeah, you could do that.
Next up, what is Woz working on now?
Okay, what am I working on that I can tell you about? I would have to look at the website. One of the public things that at the Institute that is when we get things like DARPA grants, it's publicly known that we have a grant, and there is one DARPA grant, which is sepsis therapy. So this has been addressed on the website, and I talked about one of the prototype units at the Open Hardware Summit, and I continue to work on that.
It's a vacuum. It's a vacuum cleaner.
It's a vacuum cleaner for your blood.
Okay.
But actually right now I'm trying to learn as much as I possibly can about blood handling equipment and how it works and hospital safety standards. But then, I mean, I can talk about what's on the Beast website. And so anything you see that comes out of anticipatory medical devices, I'm working on that. And then outside of that, I'm pretty much done renovating a house. So I have to figure out what my next outside of work projects are.
Okay. Next up, where do I plug the coin and reader cables in the 4-coin
Post in the
acceptor?
forums. This is a technical support question.
Okay.
Can't answer it.
Any
on
way to make
engineer.
GPS work without line of sight?
No, it has to. The antenna has to basically be able to see the sky. Or it
Okay.
won't work.
I have a Mega 2560 connected to 3 RGB controllers via serial sending commands to order them all to do X. Would I2C be better?
It depends on how fast you
Yeah.
want to send this data off.
Like, you definitely don't with I2C. So with I2C, you have to talk to each slave serially.
You can only use one I2C line, so it's much
So
slower.
it's actually a lot slower. If you're trying to tell 3 modules to do the exact same thing, you set them up so that it's basically the slave does not acknowledge. And so it's like the master just broadcasting.
Yeah, but you don't.
No. I mean, like on serial, it's easy. It's easier. Like with I2C, it just gets slowed down. And if you're, trying to do real time RGB,
I guess it
light
depends.
switching.
It depends
it's
a
not
lot
gonna
about
be
it.
fast.
If you post in the forums, you can answer in detail, but it sounds like it's a complicated thing because obviously there's.
Yeah, but I don't think I2C would be better because it's already limited to 400 kilohertz.
But I have no idea what his project is.
It's true. I mean, unless I2C gets you something with the module that
Okay.
serial doesn't.
Okay. What can I do with a constant current power supply from 1964?
Charge batteries. Batteries love constant current.
Okay. Is there a source for the HT16K33 drivers using LED backpacks, and/or do you know of any compatible chips?
Nope, this is the only chip we found, and we have to order them direct from the factory in gigantic quantities. So there's no distributors in the U.S. that I know of.
Yeah. Is there available video of Lady Ada's Rockefeller interview? They said they're posting it. If they don't, I have one, and I will. Next up.
So there.
Yeah. What resources do you recommend to start learning RF design on PCBs, antenna design, etc.? Is there a book somewhere that I should just buy, sit down, and read?
Yeah. So there are a bunch of different.
Sounds impossible.
There are a bunch of different books, but there is
Just
a
read
really
the
good-
ARL handbook and be done with it.
Well, there's also microwave electronics designed by Posar. PUOSAR. That's not actually the name of the book, but the Posar book is like everything you wanted to learn about microwaves and transmission line theory, which you need to understand sort of how antennas work. It's the basic RF introduction book. It's a little thick to get through, so you need some of that. Stalin and Rosen? Stalin,
I didn't take
Rosen.
6113. I skipped that class. I hate that class.
There is, I mean, a lot of the books are super math heavy, but in terms of PCB layout rules for analog, yes, I can. I never remember the name of the layout guide I have, but there's one that I believe is from I believe it's from either Maxim or Linear. They have a really, really good layout guide. And it's like a 30-page introduction to RF PCB layout. I'll have to send that PDF
or
to
you can just read the ARL handbook.
The ARRL handbook has like tons of really great circuits too. And the nice thing about it is
there's no math in it.
well, that's the thing, is it's very human readable. So it's not like, let's prove like the fundamentals of the Smith chart and go through all the complex transformations for you, which is what the engineering textbooks have. So if you're not ready to revisit complex algebra,
You can pretty much guess it if they're in the chat. They don't.
yeah, but that's so ARRL is super practical, and get the most recent edition of the handbook and read through it.
Okay. Next up, when will Ada Vision be back up?
We don't know yet. There's no ETA.
Okay. Next, will Adafruit have a table at Hope presenting? No, but
Nope.
we'll be there for fun.
We'll probably be attending, but we won't be presenting.
Yeah. Can an off-the-shelf pulse oximeter from a pharmacy be hacked to read the measured values from the microcontroller? Do all these devices work similar to the kilowatt hack?
No, it's completely different than a kilowatt hack. You'll have to do a lot of
You have to
math.
open it up and
You have to open it up and do a lot of hacking, and it probably isn't something you can read off of.
do the pulse oximeters have digital display out, like telling you
Yeah,
what your
but it's like
SpO2
an
is?
OLED. You're not going to be able to get to it.
Well, then something is.
Basically, no.
Okay.
I would have to
The
open it up and
kilowatt
check.
was a very because it's analog. It was a very special exception. You could just hook up to the op amp and be done with it.
Oh, so these are OLEDs instead of.
It's an actual display.
Okay.
Someone says Microwave Engineering is a good book for that previous question, by the way.
Right, I think that might be the post.
Someone wanted to know what class does cover it. The things they asked before.
So
What?
at MIT,
What class?
what
where,
class covers
What class? Where?
RF design?
Yeah, the RF design. Yeah. there's some-
6013 covers fundamentals of RF and basically like transmission line theory and applied engineering for that, but that doesn't teach you RF PCB layout. RF PCB layout I learned from talking to more experienced engineers, and so when I was at Analog and working on the HDMI product series, I was working with one of our CAD engineers to do basically the applications board for these HDMI multiplexers. And so I learned from Mike, and I learned from Bob, and I learned from Maury all of these rules about high-speed PCB layout because they've been doing it for 20, 30, 40 years. It's only a couple of times that that really, normally the textbooks, like Poser's Microwave Engineering, are not targeted at practical applications because everything's application specific. So you learn it by experience, or you learn it from the people who know. So definitely.
Basically, it's not teachable.
It's teachable, but everyone goes, oh, that's like an ITT tech class, because it's too practical. A lot of times, designers are not the ones necessarily doing their own PCB layout. Usually in industry, it's split. So you've got to get in and get your hands dirty.
Okay. Next. Any advice for cleaning PCB after soldering? Anything I should read?
For cleaning PCB after soldering, so from any of the stores, and I like to use Allspec to get my supplies. There is PCB cleaner, but the most basic thing is just isopropyl alcohol. So there are these nice anti-static ESD or ESD safe horsehair brushes, basically, or fiber brushes where you put isopropyl on the board and you scrub at it, and that actually takes off the flux residue from soldering. And then the best thing to do is then you flush it over again with isopropyl, and you can get nice dispenser bottles, like spray dispensers, or one of the technicians at Analog had.
You have to get cleanable flux rosin, solder.
And then
you can't use no clean and then try to clean it off. It won't work.
It'll kind of work, but not really.
It looks like a mess. You have to get water soluble or just active flux.
Yeah.
And then you can clean it off.
But they make you can get at Allspec these nice basically solvent dispensers, and then the fastest way to get it clean, because if you could just keep on doing that, it evaporates and then re-deposits back down on the board, is you take compressed air and you blow all of the liquid off of the board while the like while it's still in, soldated.
Okay, I'm gonna skip.
I just use no clean.
I'm gonna skip one and then
Never
go
really
back.
worked for me.
Is 70% isopropyl
Doesn't
good
matter.
enough
Who
or
cares?
91%?
70% is good enough, but like 91% is always better. And cotton swabs, unless you get really, really good ones that are meant for this, that are like super densely packed and pointed, always shed all over your board, so try not to use those.
Is there a decent hobbyist shaft encoder other way of measuring rotation?
I don't see why not.
Use shaft encoders.
Yeah.
You can use a Hall effect sensor.
There are lots of ways to
But then
measure.
it's not even. It's
Yeah.
not going to vibrate.
Yeah.
Shaft encoders are fine.
Okay. We got like time for like one or two more questions, and then we're gonna do trivia question, and then we have to get that cat. So, any more questions before we move on to the trivia question? That was a good run of questions.
Nope. Nope.
Going. How to measure the health of 400 AH AGP batteries?
I think aren't batteries, they usually measure like how they're doing in terms of discharge time and charge time.
Yeah, I think so.
So you look at like a battery that's near the end of its life will discharge much more quickly. So under a specific load, you look at how tired it gets.
For the ESR, probably that probably goes up with like the.
It depends on the battery chemistry.
Yeah.
But I'm not.
Imagine it goes up.
Yeah, but I mean, I would just like have a, time A to time B known load and look at how much it discharges in that window, and that'll tell you the health of the battery.
Okay, two more questions. One, what type of beer is that?
It is Sierra Nevada Summerfest, crisp
Okay.
summer lager.
Oh, I'm sorry, I might do two more questions. Oh wow, no, there's three. Any work with defibrillators? Have you ever done anything with that?
I have not done any personal work with defibrillators. I have gone to a number of presentations from Medtronic and other companies on their AEDs. I've gone to reliability training seminars that covered sort of the design of the defibrillators that you see in every hallway and how that differs from the defibrillators in an ER. They're pretty awesome systems, but I work on the research side, and that's all done like in mass market.
Okay, more questions. Geez, now they all pile in. You have updated a lot of sensors to be 5-volt capable. Is 3.3 volts still better to use to avoid those?
You can use either one.
Yeah. 5-volt are Arduino compatible, so
Yeah.
it's easier that way.
Some breadboard
Yeah.
chips
All
or
right.
5-volt.
Tips for keeping your shop clean when you have 100 projects going on.
Bins, just like have project bins. Make it easy to get to. Don't have crap-avalanches. Don't just like drop everything. I mean,
Crap-avalanches.
we have crap-avalanches all the time. You have to just try to keep it organized.
Yeah.
Make sure you have enough storage space. Invest in like nice little parts bins like you have, and project bins.
Yeah.
That's all you can do. Clean up after yourself as you go. It's just like, how do you keep the kitchen clean when you're cooking all day?
Yeah.
Engineering is exactly like that.
You have your wife do it.
Well, then you're not a very good engineer.
Alright. Okay. That's it. You guys are done with questions. Congratulations.
Yay!
Alright. It's time for trivia questions. Trivia question. Alright, Lady Ada, what are the rules?
Rules are, if you've won a prize from our trivia giveaway, you can't enter this, so type it into another window, or sit on your hands, or, I don't know, do something, but don't enter it because we keep track of who's won, and it would be very sad if we caught you trying to win 2 prizes. And then, if you know us, you can't enter, and the first person with the correct answer with spelling in the box wins.
Okay, so you're going to have to type in the right name of this dude.
Do you want me to say what the prize is, or do you have a prize in mind?
Yeah, it's going to be one of the little screens.
You get to choose which side screen you want.
Yeah. So
That's great.
this person was an American inventor. He had over 180 patents. He invented the Audion. It's a vacuum tube that makes relatively weak electrical signals and amplifies them. He's known as one of the fathers of the electronic age. So for you radio geeks out there, no, it's not Edison. Oh! As Terrell, lead to Forest. You got it.
I bet everyone is just typing in Tesla, huh?
Yeah,
not Tesla,
so
though.
I know, but everyone I was just like Tesla.
So he was let's see, where'd that person go? What was her name?
Tesla's the answer for many things, but not for everything.
Yeah, the person who won, where'd they go? Forgot their name. Anyways, email support@adafruit.com.
Okay.
This guy's interesting. He's one of the charter members of the Institute of Radio Engineers, one of the predecessors of IEEE. DeVry University was originally called DeForest Training School after him. And he also was married 4 times, one of them over, like, wireless.
Whoa, like the
Back in
ceremony
the day.
conducted. over-
Yeah, it was weird. It was a little weird. Things got weird. All right, so that's it. So as told, I think that's the person who won. Send a note to support@adafruit.com. I am going to find that cat. Could you do another little tour of Circuit Playground?
Yeah, well, do you want to do some op-amp calculations?
Yeah, so why don't you guys do that?
Hold on.
Just make sure you look at the screen because it needs to focus in.
Okay, so
What are you
let's
calculating?
see.
Maybe a diff amp?
Yeah, actually, difference amplifiers are a lot of fun. So I really like that the formula is here. Times V2 over V1. I'm gonna say that that's times V2 over 5. You have to like have common mode. What's the common mode range? Let's just do this around mid-rail.
I think it's assuming plus, like, positive and negative.
I think it really is assuming plus or minus. Well, no, I think it's assuming 5 and ground, or do you think it's...
No, it's positive and negative.
Positive
It's
and negative 5 volts?
ground is middle voltage.
And then you can just
Yeah.
type in K,
You
right?
can type in K. There you go.
Nice. R2 over R1. So then that's... Let's do like... Oh, 5K5. Hey, will that do the right... Yeah! So you can use like whatever notation you want. That's pretty sweet. Let's repeat that for those at home. Whoa, whoa, whoa. So if I want to do like 3K8, if that's your preferred notation, that's really nice.
Look at that.
Oh, watch out. Cat and beer. Don't mix.
Do not mix.
Yeah, so
Mas.
he's going to say hi to the camera. All right,
Watch
MOSFET.
out. Oh.
Sometimes he meows.
Meow.
Meow.
MOSFET is solid.
Meow.
We need to heat sink him. It's too hot.
Meow.
Oh.
No.
Here.
Oh.
Yeah, it's a lot. Okay.
Hey there, little guy.
He's very loud when we're not in front of the camera, but I think he's shy.
Yeah. Special thanks to
Can you take him?
Becky for showing up, George for doing the recording. Good job. Get a little
Yeah,
here.
MOSFET
there you go.
for being tolerant. Thanks, MOSFET.
For Waz showing up. For Phil Paint Your Dragon doing that awesome project. Colin for the great updates on the iPad app. And as always, everyone, thank you for showing up on
And asking good questions.
Yeah, great questions this week. Don't forget to vote so we can make this Lego set happen, because when this happens, then we're going to make an Amanda biohacking one. We won't stop. We're not going to stop.
In the biohacking lab, you have to wear closed-toed shoes and no Crocs.
It's a common problem.
Yeah, people wear Crocs to lab.
Yeah.
I don't understand why it's
All
not
right.
safe.
And we'll see everybody next week. Here is your moment of Zener.
Ow.